the midterm exam, okay, is a magnified giant quiz, okay? So it's going to be this weekend, okay? Friday, Saturday, Sunday. And you have 3 attempts. And each sitting, I will let you know how much time I give you for each sitting, but you have 3 attempts. Make sure you find, you know, the internet connection that's reliable, because you're not going to have more attempts. You're not going to have longer time. So you must make sure that you are, you know, you have set your test so that you can complete it with the best possible condition and the best possible preparation. And meanwhile, we will still continue our topics. We can still continue our topics. You can see we still have much to do. And this semester, we have focused on function from the outset. And as far as summarizing what we have done for the semester so far, I'm proud to say that we have covered all of these functions early. We have covered all these functions early. So far from the beginning of the semester until now, we're really focusing on this concept and this concept only, function. A function is a rule. So we have talked about 22 rules. With you guys, we didn't cover arc cotangent, okay? But I posted a video, a recording on cotangent last week. Okay, I sent you a message. I hope you guys have a chance to you know, to practice, to watch and practice. And your homework last week related to arc cotangent and its related topics. If you have any questions, then bring them to me. As you can see, right, we talk about from the beginning of semester, in mathematics, there are only 2 kinds of sentences. There are 2 kinds of sentences. One is a statement. So this statement is basically sometimes it just say something, it's a statement, right? Whatever that statement is. It could be a narrative of a rule, okay? So these are statements, okay? Every one in this table is a statement. This statement is a narrative or description of a rule. And that rule is a function. And what is a function, right? And we know every one of them is a function here. We have talked about all of them, right? And we know the function we will encounter in life, in the actual coursework, sometimes is a combination of them, adding, subtracting, multiplying, dividing, or composite of these functions, right? So that's why we call, you know, I coined the word basic functions. These are the basic functions. Are you going to encounter them? Yes, absolutely. Okay, absolutely. Now, with that said and done, we're going to talk about another kind of sentence, okay? Another kind of statement, right? So we said there's a statement and there's an if statement, right? So let me write it down, Friday through Sunday, okay? Now, so we have the statement here, right? So these are the rules. Now, we have 2 kinds of sentences, statement, and the other one is if statement. We haven't dealt with if statement that much yet. Okay, so we have statement, we have if statement. So function actually falls in the category of a statement. Okay, it's a description of a rule. okay? Description of a rule. Some of the textbooks actually confuse function with equation, okay? And I have seen a lot of mistakes like that, But I don't want to dive into that correction part because that's going to be just too messy, okay? Next is we're going to talk about if statement. Okay, so that's what we're going to cover next, the if statement.
Professor, I have one quick question.
Yes.
How much time do we have for the midterm exam?
I said I haven't decided.
Oh, okay, my bad, sorry.
I will let you know before it happens. You should have enough time. Okay, any other questions? The other thing is I sent you the messages, you guys see it, right? That I have made all the quizzes available with the solutions and your answers. Your answer solution, they're available until Thursday night, for your review, So Friday morning, you will see the midterm exam. But at that time, all the quizzes are closed, including their solutions. You probably can still see the quiz, but you won't see the solutions. You want to see the solutions. All right. So that probably tells you something, right? So when you review, you want to review the course, the recordings, and of course, lots of recordings, but you also want to review the quizzes. You want to review as much as possible. For some of those important topics, because you have 3 attempts to do the midterm, okay? So in between, you should plan some time for you to watch some recordings during that time, okay? Between the quizzes, between the different attempts, right? Before you take the first time, you want to watch some recordings, some certain part you don't understand, or certain quizzes you didn't do well. And then after your first attempt, before you try the second attempt, you want to watch some of the recordings, okay? And so on and so forth, okay? The purpose of this exam is really, I want you guys to go back to the lectures, to go back to the basic concepts, and in that sense, that's my real goal. Okay, to really try to understand, It's not about memorization. At all. It is about understanding. Okay, so with that said and done, we're going to get to the if statement. Okay. We have spent the entire first part of the semester, 7 weeks, I would say 6 weeks, right? If we put aside the mathematical principles and the truth table, right? Mathematical principles and truth tables aside, we spent about 6 weeks, maybe 7 weeks, right, on these functions. And at the beginning of the semester, you should understand how important these functions are, okay? We have discussed domain, range, intercepts, and these rules and how the domain and range are set that way. So without these basic understanding, it's pretty difficult to continue. Okay? So these are just in one category of mathematics. If statement. What is if statement? Right? What is if statement? So I'm going to talk about what are if statements. Okay? The first one, the if statement, you might have seen it. Say 2x minus 1 equals to 5. Examples. Okay, this is one of the examples. This is actually an if statement. Okay, in the future, when you start doing programming, you will understand exactly what I meant. okay? Because computer science programming adopt the same two structures of sentences. Then they have in computer science, one is called assignment, which is the rule, right? And the other one is if statement. There are many different kinds of if statement in programming. They're looping, there are all kinds of loops and iterations and stuff like that. They're all categorized as the if statement. But we are talking about mathematical. We're talking about mathematics, right? So why do I say this is the if statement? Everybody know what to do with it, right? Does everybody know how to solve this?
Yes.
Everybody knows. So I'm not going to go over how to solve it. I'm going to talk about the meaning. What it means. It means if 2 times an unknown number minus 1 is 5. That's the if statement I meant. So when you see that, that's what it meant. That's what it meant. You guys follow me? If 2 times an unknown number minus 1 is 5, and then what you do? You're going to find all the possible x, all possible values for x. And this kind is called what? This category has a name. They are called equation. They're called equation. Okay, so you have numerous examples, right? So that's example number 1. That's example number 1. Okay, that's one example. How do we solve this equation? Everyone, if you know how to solve this equation, but I do want to give you a different perspective. I do want to give you a different perspective as we're talking about this. Okay, everybody say, oh, I'm going to add 1 on both sides, divide both sides by 2. You know how to do that. But I'm going to give you a geometric interpretation of this, because this second method sometimes can be very, very useful and very, very powerful. Okay. Now, with what that means from the functions perspective, right? We talk about the theme of this course is function, right? You guys know the usual way to solve it. From the functions perspective, it says, okay, another perspective. So I'm going to write it down, another perspective. Another perspective, it says, do you have a rule? Okay, this rule takes the input, and the rule is take the input and do the 2 times the input minus 1. It produces an output, and that output is 5. So this is the function perspective. This is the function perspective. This is the function perspective. We've been dealing with this kind for a long time, right? Since the beginning of semester. This is the function perspective. If this is the functions, if this is the function perspective, we know that every function has a graph. Every function has a graph. So what does it mean? Well, if you take 2x minus 1, and you graph this, everybody should know how to graph this, all right? It's just a straight line. It's just a straight line. It's just a straight line. Okay? Just a straight line. Okay? It says, well, because this question becomes what? Becomes we're looking for input and we know the output. Okay, we know the output, we're looking for input. And what is the output? What is the output? The output is the vertical measurement, right? The vertical measurement, remember that? The vertical measurement. The vertical measurement is 5. So the vertical measurement is 5. Okay, so let me make that red. Okay, so this vertical line is 5. It's a constant function. Constant function. You may think it's useless. Now you know it's very useful. Okay, so the input. So now you get a point, right? So now we get a point. We get a point here. This point, we know the input. No, I'm sorry, we don't know the input, but we know the output. Okay, this is still about interpretation, what the meaning of this function. Okay. Now, to solve this equation is to identify the input. And of course, you can identify by graph, right? But identifying by graph sometimes is not accurate, especially you don't fall on those perfect numbers. But this is the meaning. This is the meaning. Of course, for solving this equation, you can identify the number very quickly. So the input is going to be what? It's going to be 3, right? It's going to be 3. So the meaning of this question is to identify input given the output. This idea is very, very important. Okay, this idea is very, very important. You guys follow me? In a lot of situation, we might have to use this idea to give us a clue when sometimes the algebraic methods is very difficult. The algebraic method is very, very difficult. So far, you guys may not have seen many algebraically difficult equations to solve, but there are a lot of them out there, especially as you step into calculus classes. Okay, so that's the other perspective. That's the function perspective. Okay, so to solve that equation is like knowing the output and looking for the input. So that's the other perspective. So next, I'm gonna demonstrate a couple examples. Okay. So this is one of those examples. Okay. This is one of those examples. Another example. Okay. So that's the example number 1. So knowing that I'm going to be gone for medical leave, I'm going to select some examples from your future contents. Okay. Another example I choose is going to be from basic 4. The other example I choose is from basic 4. Okay, just to give you these perspectives. Example 2, this one I chose is from basic 2. In basic 2, it says solve for x. Solve for x. Okay, take one of the examples. Right? I'm taking the first one. Why not? Doesn't matter. The absolute value of an unknown number is 3. Some of you may know how to do this. Sometimes might have forgotten. And sometimes some of you may not say, oh, I don't remember, or I've never learned. Whatever your situation, I want to give you that function perspective. function perspective. The function perspective, once again, is that given you input, and we apply that function, and this function is the absolute value function. Did we study absolute value function? Yes, we did. And the output is a 3. The output is 3. Remember at the beginning of the semester and throughout the semester, so far we talk about what you're studying is either about input or about output, which is reflected throughout the questions, okay? You only have 2 kinds of statements, okay? So I'm demonstrating to you how you only just have these 2 simple sentences, okay? So from the function perspective, we know the graph of absolute value, don't we? The absolute value function. There you go. This is the absolute value function. Right? We know it's domain and range. Right? We know it's domain and range. And we know the output. The output is 3. So this question is what? We know the output. Looking for what? For all possible inputs. That's the nature of the question. In all the problem you do, is you either look for output or you're looking for input. That's it. You guys follow me? You just have to identify a certain method. Okay, a lot of things we did in your other courses is a technique to identify them. Do you need them? Of course you do. Of course you do. Okay. But now it's time for us to have that perspective. So we know the output is 3. Okay. So we know the output is 3. We know the output is 3. So what are we looking for? These are the 2 points. We know that we should have 2 inputs for 1 output. Do you follow me? So from that picture, you know you're going to have 2 solutions. You're going to have 2 solutions. One solution is going to be here. The other solution is going to be there. So these are the 2 solutions you are going to identify. So the solution would be what? Positive 3 or negative 3. Because either will give you the same output 3. Got it? So that's the other perspective. That's the other perspective. Okay, so I pick one question from there. Okay, going forward. Okay, moving forward. I'm flipping through my notes. I hope you guys are doing the same. Okay, the next part, we're gonna demonstrate to you this if sentence, the if statement. It's in the trig section. It's in the trig section, trig 10a. Okay, trig 10a. So this will be they will make example number 3. Example number 3. It's on trig 10a. In trig 10a, we have many questions. Okay, I'm going to pick a question that is a little bit unusual. It's a little bit unusual. Okay, just to illustrate this fact. For example, I'm going to use cosine equals to 1/4. Okay, I'm going to use a cosine equals a quarter. Cosine x equals to a quarter. And this is an if statement again. This is an if statement again. It basically says if, right? Cosine of an unknown angle is a quarter. Okay. Find all possible values for x, the angles. So you basically know this. If you use the language of ARD, we know D, we're looking for A. Okay, so if you know D, we're looking for A. So ARD, this is DRA, from D to A. You follow me? This is from D to A. Okay, so I'm going to show you the different ways that this is going to work everything that we learned about trig functions together. Okay, first of all, you know this is not a special angle. This is not a special angle, right? If it's a special angle, I'm sure a lot of you, you know, you have your tricks, you have your whatever. This is not a special angle. What do you do? And then some of you may ask, is this cosine the constrained cosine or not constrained cosine? No, this is just a cosine. It's a cosine that defined on the entire number line. This is the cosine that defined on the entire number line. Okay, so now there are multiple ways to do this. There are multiple ways to do this. Let me do it the way that's maybe most visual, okay, to demonstrate the meaning I was just trying to explain to you. The function perspective. Once again, what is the function perspective? The function perspective basically said, okay, I have input, and this input is going to give to cosine, right? So the rule of cosine applies to my input. It produces output. And we know cosine definition, right? We know cosine definition. Do we know cosine definition? Of course we do. ARD, right? The angle, how x is measured, right? The reference angle and the definition. Definition is x over r if you have select a point on the terminal side of the angle other than the origin, right? So I'm stating the definition. So that's the definition. The whole stage is coming your way. The whole stage is set for us. Now, we want the output to be what? We want the output to be a quarter. So the ratio is a quarter. One way to solve this is to look at the graph. Look at the graph. Okay, look at the graph. The entire graph. Okay. The entire picture of cosine. We know the output. We know the output. Okay. We know the output. So if this is, we know this is the if statement, right? So if the output is a quarter, what does that mean? Well, if the output is a quarter, we're going to draw that constant function. It crosses the curve. How many solutions do we see? All of these are crossings. All of these crossings, every one of them has an input. And we have many more that cannot be shown because the paper and the computer is limited. We have many, many solutions. We have many, many solutions. Okay, we have many, many solutions. And your job, our job here is to identify all the possible solutions. We know the output and we're looking for the input. So there's an input here, there's an input here, there's an input here, there's an input here, There's input here, and there's an input here. And going in that direction forever, and go in that direction forever. And so when you're given this question, you're asked to identify all possible solutions. You're asked to identify all possible solutions. What do you do? But first of all, you know there are infinite number of solutions, and this is the picture should be in our head. Oh, we should expect infinite number of solutions. We should expect infinite number of solutions. So how do we identify them all? Right? How do we identify them all? Okay. By the way, the contents today will not be covered on the midterm exam. It will be covered on the final exam, okay, by the next teacher, So you should not be burdened. You should not be worried too much, okay? I just want to move forward, okay? So you have something to refer to, right? So I kind of complete my 2 sentences at the beginning. Okay, and I will have time to review for you. Okay, so if you have questions, I will use this opportunity to review for you. Okay, and primarily for this class, I'll probably review on Thursday. Okay, on Thursday. Okay, but meanwhile, you need to study the quizzes, and you need to study everything. All right. Will I give you some homework? Of course, I will give you some homework. I will give you some, but this week there's no quiz. There's no quiz. All right. So with that said and done. Okay, so you look at the perspective. Okay, I'm covering today's lecture, and at this lecture, I hope you guys will come back to see it over and over again. Okay, it's that important. All right. Now, how do we identify the solutions, right? We still need to identify the solutions. Now, you have to look in the details. You need to understand, this is the highest point and that's the lowest point of cosine, right? Can you identify these points? Remember, when we were going through arc cosine, we learned to identify those points, don't we? What is this point? And what is that point? And how far away between these 2 points? And how far away between this point and the next point? You guys follow me? Yes? Yes?
Yes.
All right. I'm sorry. These are the moment test you really have a good foundation. The first part of the semester, right? We graph those points, right? We graph all those functions. You think you just graph them and we're done with them? No, you're gonna use them. You get to use them. Okay. So now with that said and done, we know that this point, you can also use a unit circle. Remember, when we do these graphs, we always put the unit circle along with it, right? They're kind of next to each other. So the key is to identify this point, right? What would that point be? What would be the input? See, this point, right? This input is between 0 to pi, right? Because this piece is identified as the piece that we define arc cosine, right? So this point, this is lowest point. So can you mark these 2 points? This is the opportunity also we are reviewing for you. Okay. So this is the highest point. Okay, this is the highest point. But what's the coordinate of that point? What's the input output?
It would be 0, 1 for the highest point.
0 what?
0, 1.
0, 1, perfect. Okay. How about that point? How about the lowest point?
Would it be pi -1?
Perfect. The pi should be the orange, right? And the red number is the red number we have always known. Okay, so let me remove that 0 and make it orange. Right, so I'm making some connections, don't I? So between these two highest point and lowest point, between 0 to pi, that's how arc cosine is defined. So for that slice. So how do we identify this angle? This angle would be the arc cosine 1/4. Arc cosine 1/4. Okay, because we know arc cosine, the range of arc cosine is between 0 to pi, right? So this angle is going to be arc cosine quarter. Just this point, this star. If this is arc cosine quarter, so we can call it theta, right? How about this one? How far are they? How far are that? Right? How do we identify those? How do we identify those? To illustrate this, I'm going to bring you back. I'm going to bring back the unit circle. Okay, so did you write it down? Did you guys write it down? So you can go see back and forth, back and forth. Did you write it down? Because I'm going to clean this up, bring back the unit circle. All right. Okay, so where's my unit circle? Come back. Okay, I know my unit circle is not far away. There. Or either one, it really doesn't matter. Either one. Either one. Okay. So knowing cosine, okay, knowing the output equals to a quarter, right? Knowing the output equals to a quarter. This is going to be a DRA kind of question, right? You know the definition, we're looking for A. We're looking for A. So now with that in our mind, we have the curve over here, right? What does it mean that cosine ratio is a quarter? What does it mean cosine ratio is a quarter? Cosine ratio is a quarter, right? ARD, the angle we're looking for are X, right? X are angles. So we're gonna measure these angles from the standard position. We measure, measure, measure. So we want to have a ratio which is a quarter, 1/4, 1/4. So what you can do is that you can draw a triangle, okay? What kind of triangle is that? 1/4. What kind of ratio is a cosine? It's adjacent sides over hypotenuse, right? So the adjacent sides is what? Is 1. Okay, ignore these numbers 2, 4. Okay, ignore these numbers. Ignore these numbers. Okay. Ignore these numbers. I try to be as proportional as possible. Okay, so I'm just still gonna clean this. So I'm measuring my angles. starting from the standard position, and then I get a quarter. I get a quarter. So this is the adjacent side, which is the red. Remember the red we talk about? The red. And that's the blue. I'm quoting the definition. Do you guys follow me? I'm quoting the definition. We pick a point on the terminal sides of the angle. And so the red is 1. The red number is, the red piece is 1. The hypotenuse is what? The hypotenuse is 4. So that's what cosine output is 1/4 to tell us. Okay. And there's another angle, right? Because we know cosine is positive, negative, negative, positive, right? So this is one angle. This angle can be expressed. This angle can be expressed what? This angle, if we call it theta, we just call it theta, right? Theta equals what? Equals to arc cosine what? 1/4. With the same terminal, that will give us the same ratio, 1/4, there's another angle. What is the other angle? Oops. The other angle terminates in the 4th quadrant. Okay, with the same red, opposite blue. I'm quoting the definition. Do you guys hear me? So the other angle will also make the cosine ratio equals 1/4. So we have identified these 2 terminals, right? Remember, we're doing DRA, right? DRA. We know the D. From D, we identify the A. But in between, there's a reference angle R. Reference angle R is helping us to identify all the possible terminals. All the possible terminals. All the possible terminals, so that the output is 1/4. Do you follow me? So now we have identified the 2 terminals and no more. Can you find another one? I don't think so. So if this angle is theta, right? If this angle is theta, how do we express the other angle? This green is a negative theta. So you have identified 2 terminals. One is theta, which is expressed by arc cosine, and the other angle is the opposite. It's negative theta, right? Because we can measure, the easiest way to do it is measure clockwise. And of course you can do it, you can go around, you can do that too, right? So you get 2 pi minus theta, that's okay. There's many representations, right? We know that for one terminal, you have many, many representations. But as soon as we have identified these 2 angles, okay? As soon as we have identified these 2 angles, the solutions to this question identify all the input, right? So the solution would be X. Okay, one terminal is arc cosine 1/4. Okay, theta. And you can sit on the terminal of theta and plus 2k pi. Or The other angle would be x equals to negative theta. So negative arc cosine plus 2k pi. Okay, so these are all the solutions you can find. So now let's go back to our other picture. Let's go back to our other picture. Did you guys write this down? Okay, remember theta and negative theta, right? So what is the theta? What's the negative theta? This is the theta. Okay, see this point crossing, and this is the theta. So this piece is the theta. This piece is the theta. And what is negative theta? The negative theta is on the other side. Okay, so this is theta. This is the theta. And this one is the other theta. It's a negative theta. Okay, so once you have identified these 2 points, okay, so from here, you add 2 pi, you get there. Okay, so that's 2 pi plus 2 pi. From here, you subtract 2 pi. You subtract 2 pi. You get there. Minus 2 pi. Okay, that's the plus 2k pi. 2k pi plus 2k pi, you can be adding 2k pi, subtracting 2k pi. So you can keep going. And this point, okay, this point, if you add 2 pi, what do you get to? You get there. You follow me? You get there. If you subtract 2 pi, you get there. So all the points are covered. All the points are found. These are the inputs we found. You follow me? The same tools we used, we have developed, right? The curve, the correspondence, the red, the blue, okay? This is the moment you get to use it. You use an if statement. So for this question is DRA. It's from the cosine ratio to identify all the possible input. And that's the usefulness, because you also see the necessity of introducing arc cosine, and knowing all of these properties, All right. So this is the third example. This is the third example. Okay. Next example. I'm going to give you an example from Logarithm and Exponential about these kind of statements.
Professor?
Yes.
Do you think you can explain why you have to use arc cosine of 1/4?
Say it again, louder.
Can you explain why you have to use arc cosine of 1/4?
Because that's the only way to represent that angle precisely. This is not a special angle. It's not a special angle, right? For example, if you want to know that angle, typically you have to use your calculator, right? You type in arc cosine or cosine inverse or quarter that give you angle. But where is that angle? That angle has a place in the picture. That's the orange here. Do you follow me?
I see. So an example would be like cosine of 1/3, would the answer would be, or cosine 1/3 plus
1/4.
2k pi, right?
1/4. Yeah. Plus
Okay.
2k pi, and you have another one. You have a negative theta. You have a negative arc cosine 1/3 or 1/4, whatever you have chosen, plus 2k pi. So you have two. You have a family of solution, and these two families of solution are represented in two forms.
So we only use arc cosine if it's not a special angle, right?
Yeah. Well, it depends on what you have. What you have. Farouz raised his hand. What you talk? Go ahead.
Professor, in the answers, I mean, in the solution for X, you mentioned arc cosine 1/4 plus 2k pi. And with the picture you told us, we are supposed to have plus minus 2k pi. Is that correct?
It doesn't matter because k can be any integer, right?
Yes.
So sometimes you can write it in the condensed form, okay? Sometimes you write it in condensed form, plus minus. But here you don't need a plus minus.
Because the k is integer.
Because k is integer. K integer, k can be 2, it can be -2.
Thank you, Professor.
Okay, good question. You don't need a plus minus here, even though if you put a plus minus there, it's not wrong, but it's just not necessary. Okay, so if you want to have a most compact form of solution, and this will be the compact form of solution. Okay, this will be the most compact form of the solution. Oh, wait, what did I do? So this will be the most compact form of solution.
Thank you, Professor.
Did you get that, Jacob?
No, I understand.
So it looks like the
You also see the necessity. A lot of students, they can handle special angles, but they cannot handle non-special angles. That means you didn't understand. Do you follow me? This is why we say special angles are in service to ARD. If you only know how to handle special angles in this situation, then you didn't really understand. You're screwed. Because in most of the situation, you're not going to see special angles. Right? And this also demonstrates the necessity of introducing arc sine, arc cosine, arc tangent, and these functions. All right. All right. I'm kind of touching these points as more or less like an overview of if statement to make my lecture more complete, but that's not the main purpose. The main purpose is for you to have a view of this course that you really just have only two kinds of statement. You have a statement, you have an if statement. You can see throughout this notes, right? There's so many pages, but there are only just two categories of statements. One is a statement and the other one is if statement. You follow me? Technique. Do you need the algebraic technique? Absolutely. But you also need to have a proper view of what you're doing. What are you doing this for? You guys understand what I'm saying? All right. So that's example number 3, right? You can see to solve this one question, to work out this one question, right? You can employ all these knowledge we have learned, right? So let's look at example number 4. Okay. I'm going to give you an example. Say e to the power x equals to 5. This again is an if statement. It said if e to the power x, we know this function, right? This is a rule, is 5. Okay, find all possible values for x. So once again, the perspective, the function perspective, the input, we know the domain for e to the power x is all real numbers, right? So e to the power x, that function is applied to the input, and we want the output to be 5. Do you see that persistent, consistent narrative? That's what I wish you to see. Because once you have a clear-eyed view about what are you dealing with, you're dealing with a statement, you're dealing with an if statement, you have a clear logic. And that will make the practice for skill more meaningful and more sensible. Okay. All right. So with that said and done, from the perspective of the graph, sorry, what am I doing here? E to the power x. We know the graph of e to the power x, don't we? Right? We know this picture, don't we? We know this picture. And we know the output is 5. So the output is 5. The output is 5. And what is the crossing? At the crossing, there's an input we're looking for. At the crossing, there's the input we're looking for. So this point, the input is unknown. The output is 5. Right? And of course, you use definition. What will be that input? The input equals to ln 5. Right? The input is ln 5. Okay. Do you guys see that narrative? So sometimes people say, I don't understand mathematics. I hope this is my attempt to try to make you understand mathematics. Mathematics, in terms of grammar, right? We talk about grammar. Vocabulary is very rich, okay? In terms of grammar, there's just statement, if statement. No past tense, no future tense, only present tense. As simple as that. Different rules, lots of different rules. Lots of different rules. You can see we have some basic rules. But if you take those basic rules and add, subtract, multiply, and dividing, composite, you get millions of trillions of new rules. But they're all function. They're all function. Taking that concept, you go in calculus. Okay, with that kind of perspective, you go in calculus, because the first day in calculus, you talk about function. Throughout the semester, or the semesters, plural, Calc 1, Calc 2, Calc 3, and so on and so forth. From that point on, you deal with functions. What are functions? With these millions of billions of infinite number of possible combinations, and all summarized in what? In one sentence. The sentence is a definition of function. You see that powerful definition? Do you guys see that power of that definition? It's tremendous. It's tremendous. Okay? And this is the sentence I'm talking about. right? Where's the sentence? Right here, this sentence. It's huge. This sentence is huge. Do you see it? This is the power of mathematics. This is the power of mathematics. Okay. Now, I wish to give you some more. Okay. The logarithm. Right? Example number 5. Example number 5. The if statement. Okay. I'm picking one from log 15a. Okay. If I can get to this with you, that's great. If I cannot get this to you, and maybe my substitute will get them to you. Well, it depends on what material he or she wants to use. Okay, but no matter what, who does it, how they do it, just these two kind of sentences. Okay, you guys, just remember. Okay, no matter what they do, however they approach the question, two kind of statements. Okay, I've studied mathematics for many, many years. Willingly or unwillingly, or, that's my, a choice I made in my life. I haven't seen a third type. Statement, if statement. That's it. Computer programming, statement, if statement. That's it. Okay. Now, I'm going to take a simple one, okay? The first question, ln x equals to 2. The function perspective, okay? The function perspective. If you look back about all the math you have learned in the past, I guarantee every piece you learned, it falls into either the statement category or the if statement category. No exceptions, no exceptions. All right, so with that said, the function perspective, what does that mean? X is the input. If you give it to the rule of ln x, and it produces output, the output is 2. At this moment, we need to be aware of the domain and range of ln x or logarithm x. Remember, we spent a lot of time. You are going to be tested on this midterm about these basic things, The domain of ln x, right? Moving forward, we spent time to graph these functions, didn't we? We plotted points, we quizzed you. All right, so let me make some adjustment on the scale. Okay, that's ln x. We know the output is 2. Crossing. And that point is the point of connection, intersection. We know the point of intersection. That point of intersection, we know the output. We don't know the input. The output is 2. and we're looking for the input. We're looking for the input, right? Of course, if you use definition, the input is not difficult to find. The input is just x equals to e squared. Right? And of course, the function can get more and more complicated, right? And require some other properties. And I think that's all I'm going to do at this point. Okay, the if statement. The first kind of if statement we called equation. We call it equation. Okay, so let's go back to the top, right? We go back to the top. Equation. A lot of you guys know the word equation, right? Do you know the implication of equation? I hope you know now. At least you know a little bit more about it, right? Equation. So equation is an if statement. Okay, it's an if statement. But this is the first kind. This is the first kind. We have a second kind. Inequality. This is a big category. Because in inequality, it could be, at the beginning of the semester, some people ask what the meaning of these symbols, greater than, less than, greater than or equal to, less than equal to. If you don't remember these meanings, then you seriously need to review a lot about those basic algebras. Okay, I mean technique-wise. So this is another big category. And I would say not equal to is also counted as in this category. Is your if statement involves these symbols. And this one means, okay, so let me just give you a summary just in case, people have questions about it. Greater than, less than, greater than or equal to, less than or equal to, and one last one, not equal to. Okay, so I'm going to put a summary of the meaning. Okay, greater than, and this means less than. Okay, you can say is greater than, is less than, something like that. Okay, greater than, less than, greater than or equal to, greater than or equal to, or not and. Remember, and or are different. Your truth table, we have questions about truth table on the exam, right? Difference between and or. Different. Less than or equal to. Okay, less than or equal to. Less than or equal to. Okay, the last one, not equal to. Okay, so these are the second kind of if statement. Okay, the second kind of if statement. All right, let's go back to the beginning. Okay, let's go back to the beginning. Basic 5. Okay, example number 1. Example number 1, right? It says the absolute value less than 3. What kind of statement is this? It's an if statement. It says if the absolute value of an unknown number is less than 3, find all possible values for x. That's the meaning. That's the meaning. Okay, so as I promised you, we're going to look at the function perspective. We're going to look at the function perspective, right? Function perspective. The visual. What is the function perspective? Well, we have the visual. We have the visual. We did a graph, right? We did a graph. Less than 3. Less than 3. It cannot be 3, but less than 3. So what does it mean? Less than 3. So this time I draw a broken line. Less than 3. What it means is you're going to find all the inputs, okay? All the inputs, right? Your inputs given to this function produces output, but the output has to be less than 3. And we know the output is already at least 0, right? Because we already know this, right? Don't we? We know this. Is greater than or equal to 0 for any real numbers, right? For any real number x already, we already know this. So basically you want to identify all the inputs, okay? So that the output is between 0 and 3, not including 3. Do you guys follow me? So what are the outputs? What are the outputs that's at least 0, less than 3? All of these. Right? So how many solutions do you have? You're looking for those inputs, right? So what are the inputs? Well, you first identify 2 critical points. 2 critical points. What are these 2 critical points? This point and that point. In between every point, right? You have all these points, all these star points. What a common feature they have. Their input is unknown and their output is less than 3. How many points do you have? How many such input do you have? How many such input do you have? All of these. Between -3 to +3, right? I know you have learned this from other perspectives somewhere else. So your solution would be what? What would be the solution for the input? The solution would be between -3 to +3. Because all of these is telling you, right? All the star points you have here, where there are infinite of them, the input will cause the output to be less than 3. Do you follow me? Do you hear what I'm saying here? Do you guys understand what I'm saying here? That's the meaning. That's the meaning. Okay, other techniques, of course, there are many different techniques. Some people just look at the number line. right? Just look at the number line, no problem, no problem. But if you see from the function's perspective, if you see it from function's perspective, that's the implication. That's the implication, okay? Now, let's look at another example, right? Let's look at another example. This one is going to be basic 6. Basic 6. Okay. Take the example of absolute value greater than 3. Greater than 3. Right? So what would that mean? Larger than 3? It's pretty much mean the same thing, except you want the output to be positive, to be greater than 3, sorry, to be greater than 3. Okay, so you still have that input. Okay, and the rule here, and you want the output to be larger than 3. Larger than 3. So where do you find those numbers? Where do you find those numbers? You identify these 2 points, right? And what are the input that will cause the output larger than 3? These are larger than 3. These are larger than 3, right? Larger than 3. So where do you find your solutions? Your solution would be more than 3 or less than 3, less than -3. So this number is -3, this is a +3. So the final solution to that inequality, of course, you know that's an if statement, is x less than -3 or x is larger than 3. Right? Which is marked by these greens, not including, you guys understand that's a circle. That's a circle, right? That's a circle S3, -3. You got it? So let me make the circle a little bit better. Okay. Circle, center. Okay. So that circle over here and over there. Right? So that's the if statement I'm talking about. Let me give you a few more examples about these if statement, right? Across the pages, right? I'm going to take you guys to trigonometry. Trigonometry. We spend so much time on trigonometry, right? Trig 12a. Trig 12a. Trig 12a. Right? What about trig 12a? What time is it? Okay. Time flies when we're having fun, right? So sine x, the first one, I'm picking the first one, larger than half. Larger than half. How do we solve this? No mistake about it. The sign refers to the sign with all real numbers as domain. Okay, you never have to have a question about that. No worries about that. Okay, this sign refers to the sign with all real numbers. So we know that curve, right? We know that curve. I can show you more of that curve. I can show you more of that curve. Right? You see that? We can show you more of that curve. What does that mean? It's an if statement. It's an if statement. The input is x. Sine x is a rule. Okay, we know that rule is more complicated than a lot of other rules we learn. And the output, we want the output to be larger than half. Larger than half. What does it mean it's larger than half? Well, if I draw half, red, broken. That's the half. The red line is y equals to half, that constant function. What do we want for the input? We're looking for input. We're looking for the angles. But the angles need to make sure the outputs are larger than half. That's the question. That's the question. And where do you find those angles? And we realize we have lots of them. We have lots of them, right? So what are the pieces that have output larger than half? These pieces. Will you be having similar questions in calculus? Absolutely, you will. Okay, so how do we identify? Look and see, our solution is going to be, you know, all these small intervals. We have many of them. How do we identify them? How do we identify them? How do we identify them? We start from the simplest, don't we? We start from the simplest, right? We know that this point is not a solution, right? That's a circle. But we know what that point is for, right? What is that point? What are these points? All of these points in the circle, they have the same output half. And we want larger than half. We want larger than half. Right? So above half is larger than half, right? Above half is larger than half. So we want to identify all these intervals. Okay, all these are our solutions, right? Because we want to identify the input. We want to identify the input such that the output are larger than half. So you first have to understand the question. The question is to identify all the possible input such that the output are larger than half. And you have all these bits and pieces. You have these intervals to be identified. We start from the simplest. We start from the simplest. First, can we identify this point? Can we identify this point? Remember the point identification we did when we graph sine? Do you think that's totally useful or totally useless? So what will be this point? What will be this point? This point is pi over 6 half. In fact, that half should be in red, in blue, sorry. Okay, let me rewrite this. This turned out to be a special angle. I can totally give you a non-special angle. You will have to use arc something, okay? So this is the pi over 6. I'm making connections with what we learned before. Pi over 6. And the blue. Okay, how about the other point? How about the other point? This point. You can also use the unit circle to identify that, okay? The other point, okay, so let me just finish up this one. I'm going to bring up the unit circle, okay? And this point is what? This point is, the orange is 5 pi over 6, comma, the blue 1/2. Once you have identified this point and these 2 points, you can get these other points because all you have to do is just add or subtract 2 pi or 2k pi. You guys follow me? Right? Because from here to there, that's 2 pi. From here to there, that's 2 pi. From here to there, that's minus 2 pi. From here to there, that's minus 2 pi. Do you guys see that? Ah, you see those basic things we did, how important they are. How important they are, right? So you shouldn't be surprised. And I'll be testing you on the midterm about domain range and some points, identifications, right? Yes? Should you be so totally surprised? You shouldn't. You shouldn't. They're useful in many ways. They're useful in many ways. Okay, so without further ado, let's look at how we're going to see this from the unit circles perspective. Okay, from unit circles perspective. Okay, so look at where's my unit circle. Okay, so I'm going to take this, right? Once again, this is a DRA question. This is a DRA question. This is a DRA question. Okay, this is DRA question. We want the output to be larger than half. We want the output to be larger than half, right? So let's look at where do we get those larger than half blue numbers, right? Where do we get those larger than half blue numbers? Where do we find them? This is a half exactly, right? This one is less than half. I'm sorry, larger than half. Larger than half, larger than half, larger than half, larger than half. So all of these angles, remember angle measurement? From here, okay, to here, and this piece, every terminal that terminates from here to there, exclusive, those blue numbers are larger than half. Do you agree with me or not? Do you guys agree with me or not? Do you look at the blue number? They're all larger than half, right?
Yes.
Okay. Do you guys see the importance of ARD? Do you see that? ARD. I'm using A, how to measure angles. Right? Do I find more? No, all the rest are negative. So all I need to do is identify these two numbers, these two terminals. So one of them is what? One of them is what? Pi over 6. This is pi over 6. And the other one, what is the other one? 5 pi over 6. 5 pi over 6, right? 5 pi over, remember we marked 5 pi over 6? That's a 5 pi over 6. How are they measured? They are measured in the way stated by ARDA. You follow me? So ARD is constantly, it should be constantly in your consideration. And they will not change. That's why they're called the 3 pillars of trigonometry. Those rules do not change and they will never, never, ever change. Question changes, but these rules do not. right? So you, as long as you stick to them, you'll find a way. So you identify the pi over 6, 5 pi over 6. So let's go back to the picture, right? So this point, right? That point, what point is it? Remember, I painstakingly asked you guys to mark points, mark points. What do you think I asked you to do that for? For moments and many moments that coming your way like this. Okay, this point, right? So what are these points? This point is pi over 6, comma, half, the blue number. And that point, and that point. I'm sorry, I didn't give you much of opportunity to do exercise today. I want to give you an overview. And the orange color, you know what I refer to. The half, you know what I refer to. In the blue colors, you know what I refer to, don't you? And what if it's not a special angle? Now you might be thinking about that, right? What if it's not a special angle? If it's not a special angle, you can use arc sine, arc cosine, depending on what the situation. Do you see what I meant? Okay. So now, how do you describe the solution in the end? How do you describe the solution in the end? Right? Because we want to describe those input. We want to describe those input between these two green dots, green circles. And there are many more. There are many more. Right? There are many more. How do you describe them? How do you describe them? That's, of course, we're gonna have to use mathematical language, right? We have to use mathematical language. So let me show you how you describe them. This interval will be described as the solution is between pi over 6 less than x less than 5 pi over 6. How about the next one? The next one, you pi over 6 will be adding 2 pi, 5 pi over 6 will be adding 2 pi. Yes? So for all of these, right, we have many such green pieces. We have many of these green pieces. How do you describe all of them? You must describe all of them if necessary, right? In many cases, necessary. How do you describe them? Right? You can, for the other one, right? I'm just give you an example, okay? That's gonna be pi over 6. For the next one, you can just plus a 2 pi. And that one plus a 2 pi. Okay, so if you go left and right, multiple k pi, so in general will be 2k pi. Okay, but sometimes you may have to switch this. So this formula doesn't work always, especially when you have a negative number. So I will use these k's are for k is positive. K is positive integers. How about for negative? How about on the other side, right? How about on the other side? On the other side, we have to do this. Okay, this is beyond this, you know, the coverage of this course, but I still want to give you the right answer. Okay, so if it's plus 2k pi plus 2k pi. Okay, you guys can study this. If you find there's any discrepancy, let me know. Okay, so k, it will be negative integer. Okay, it's mainly between the handling of the sign. You guys will not have to deal with this in this course, but you might have to deal with something like this in calc. Okay, even in calculus, you probably will not deal with such complicated situation. Okay, so don't worry too much. Don't worry too much. I'm just giving you a perspective. I'm just giving you a perspective. Okay, our time is up. Okay, our time is up. So these are the two statements, two kind of statements you are dealing with. Okay, I hope this is an overview, because as we're getting into the if statement. So from tomorrow. Okay, and as you can see, the coverage of today's lecture will not show up on your midterm exam, but I consider this as very important overview in terms of my overall semester plan, which I unfortunately cannot carry it out completely with you. Okay, but I do want you to keep these in mind. Keep these two kind of sentences in your mind, and I hope that will be. And I'm certain it will be helping you as it has helped me tremendously. Okay, so the way I teach today is very much a reflection about all these insights I just shared with you guys. Okay, so without further ado, I will see you guys tomorrow. Okay, so you should continue. You should just get started to review if you haven't started already. All you understand the quiz, the solution to the quizzes, they're not available forever. They're going to be closed as soon as the midterm exam started. This midterm exam starts, so you have to be aware of that. So you need to spend time to get on the way to review. Really understand those lectures, and I hope, and I will see you guys tomorrow, and I will take your questions. And if you don't have questions, of course, I'll move forward with the plan. And Thursday, I will make time for you to give you a general overview and review of what we have covered up to this point, up to, you know, right before the exam. And then we go from there. All right. And I will also let you know the definitive date that I will be out. Okay, because I will see my surgeon today to discuss the details about the surgery and set the date. I will miss you guys terribly. Goodbye.
Wait, I have one quick question.
Sure.
The quick question I have is, do you have any like examples or assignments you can give for like the reference angle, where you have to do like 360 plus 70 is equal to a certain degree?
I didn't quite get your question. There's some background noises out there.
Okay, that's my dad talking. Sorry.
No, that's okay. Can you type your question?
Yeah.
Thank you, Mark. Is there any homework examples on reference angle? Yes, absolutely. The homework, like the homework I give you guys on trig 4a, right? Trig 4a. So the question is there any homework examples on reference angle? Right, for that question, I would say trig 4a. Trig 4a. At the time I was asking you guys to do this homework, I was asking you guys to please do it with ARD. Do it with ARD. When you do it, you want to be aware of ARD to do every single one of those questions. And then you can see you have to do reference angle. Do you follow me? So there's
Yes.
one thing that how you do the homework, right? Some people just say, oh, I know the inner circle, I just go there and get the numbers. No, that's the wrong way to do it. That's a way, I would say that's a waste of time. That's a waste of time. You don't get the training you needed. Okay. For example, if I were to do number 36, right? Number 36 is asking me to find tangent of 7 pi over 3. 7 pi over 3. My intention, okay, my earnest hope you do it with ARD is to do it the following way. Okay, whether you use your unit circle or not, it really doesn't matter, right? Your A is 7 pi over 3. That's your A. That's the A. Right? 7 pi over 3. So then you trust me, you're gonna do this faster and faster, right? And eventually you're gonna do it in your head. But that's beside the point. You have to go through that process. A, this is a positive angle, so you measure counterclockwise. 7 pi over 3, this looks like you're gonna go one cycle and you end up here. You're already doing A. And what's the reference angle? The reference angle, of course, is pi over 3. And then you get that tangent, you take the blue number, divide by the red number. There you go. Do you understand what I mean here, Jacob?
Yeah, I see.
So the ARD is, you know, when I make those assignments, I constantly mention that please do ARD, please do ARD. If you want to do more, Jacob, you may want to do trig 4b. Okay, because I have all kinds of positive angle, negative angle, but there are no other kinds of angle, by the way. You either have positive angle, you have a negative angle, no other kinds. But as long as you have those have the process built in your head, in time, this process is going to be automatic, natural. In the end, freedom.
I see. Thank you so much. I have to get going, but thank you so much for
Absolutely.
that.
Very good job, Jacob. Okay, great job.
Thank you. Bye.
I'll see you tomorrow.